Today we are going to learn about deploying TensorFlow models on mobile devices. We will explore the process of converting and deploying TensorFlow models on Android and iOS using TensorFlow Lite, equipping you with the skills to create scalable AI applications. To kick things off, let's delve into TensorFlow Lite, a lightweight solution for deploying machine learning models on mobile and edge devices. This tool is crucial as it enables the execution of models on device, ensuring privacy, reduced latency, and offline capabilities. By leveraging TensorFlow Lite, developers can harness the power of AI directly on mobile platforms, thereby crafting more responsive and efficient applications. This is essential for applications that require real-time processing, like augmented reality or real-time translation. Throughout this video, we'll explore how TensorFlow Lite makes it possible to convert and optimize models to run effectively on Android and iOS devices.
The first step in deploying a model to mobile is converting it into a format that TensorFlow Lite can use. The TensorFlow Lite Converter is a tool designed for this purpose, supporting models created with TensorFlow's high-level APIs such as Keras. To convert a model, you begin by saving it in a format TensorFlow Lite recognizes, such as a saved model or a Keras model. With the TensorFlow Lite Converter, you can transform this model into a .flight file. It's important to note that during this conversion, certain operations might not be supported, which could require modifying the original model. After conversion, it's crucial to verify the converted model to ensure it maintains its expected performance and accuracy. This verification can be done by running inference tests to compare results before and after conversion, ensuring consistency across the board. Model optimization is a critical part of deploying deep learning models on mobile devices. Optimization primarily focuses on reducing the model size and improving its inference speed without significantly compromising accuracy. One of the most effective optimization techniques is quantization, which involves reducing the precision of the numbers used in the model, thereby decreasing its size and speeding up computations. TensorFlow Lite supports various quantization strategies, such as post-training quantization and quantization-aware training. Additionally, pruning and clustering techniques can also be employed to further compress the model. The goal is to achieve a delicate balance where the model is lightweight enough for mobile devices but still maintains an acceptable level of performance.
Utilizing the TensorFlow Lite Converter is a pivotal step in the deployment process. The converter can be accessed via a command line interface or a Python API, providing flexibility depending on your workflow. To initiate conversion, you specify the path to your saved model or Keras model, and the converter generates a .flight file. During this process, you might encounter unsupported operations. When this occurs, TensorFlow Lite allows you to create custom operators or adjust the model architecture accordingly. Debugging conversion issues often involves checking error logs and ensuring all operations are compatible with the converter. Once the model is converted, thorough testing is needed to confirm that the model's performance meets your expectations before deploying it to a mobile application.
Deploying TensorFlow Lite models on Android involves several steps, starting with setting up your development environment in Android Studio. After integrating the TensorFlow Lite library into your project, you can utilize the TensorFlow Lite interpreter to load and run models. The interpreter is responsible for executing the model's operations on the device's processor. It's crucial to handle input and output data correctly, as the model's input shape and data types must match exactly what the model expects. Android developers often use ByteBuffer or TensorBuffer to manage input data efficiently. Once set up, you can run inference on the device, processing input data through the model and retrieving the output. This output can then be used within your application to provide AI-driven features, such as image recognition or natural language processing. For iOS applications, integrating TensorFlow Lite models requires a similar approach to Android but with tools specific to Apple's ecosystem. Start by setting up your development environment in Xcode. You can incorporate TensorFlow Lite by using CocoaPods, a dependency manager for Swift and Objective-C. Once the TensorFlow Lite library is included in your project, you can use Swift to interact with the TensorFlow Lite interpreter. As with Android, correctly managing your input and output tensors is essential. Swift provides a seamless way to handle these operations, ensuring that your data is processed accurately according to the model's requirements. By following these steps, you can execute model inference directly on iOS devices, unlocking advanced AI capabilities in your app.
Incorporating model updates and versioning is an integral part of maintaining AI applications. As models evolve, they require periodic updates to improve accuracy and adapt to new data. Version control is essential to manage these updates, ensuring that changes are tracked and reversible if necessary. Implementing a versioning strategy involves tagging model versions with identifiers and maintaining backward compatibility to avoid breaking existing functionality. Automating model updates can streamline the deployment process, ensuring that new models are seamlessly integrated into mobile applications. Before releasing updates, thorough testing is crucial to verify that the new model performs as expected and doesn't introduce regressions. This ensures a smooth transition for users and maintains the reliability of AI-powered features.
When deploying AI models on mobile devices, performance considerations are paramount. Mobile devices have limited resources compared to desktops or servers, so optimizing the model's memory usage is crucial. Efficient memory management involves using lightweight data structures and minimizing memory overhead. Balancing energy consumption is another important factor, as AI models can be resource-intensive and quickly drain battery life. Techniques such as model quantization and using hardware accelerators can improve execution speed while conserving energy. Ensuring a smooth user experience involves optimizing the model's inference time so that it operates seamlessly within the application's workflow. By addressing these performance considerations, developers can deliver AI applications that are both powerful and user-friendly.
As we conclude, it's clear that deploying TensorFlow models on mobile devices using TensorFlow Lite opens new horizons for AI applications. On-device AI offers numerous advantages, including enhanced privacy, reduced latency, and offline capabilities. By following the steps outlined in this video, from model conversion and optimization to implementation on Android and iOS, you can successfully bring powerful AI features to mobile applications. As mobile AI continues to evolve, staying updated with the latest trends and techniques will be crucial. We encourage you to start implementing these strategies and explore the vast potential of deploying AI models on mobile platforms.